Hi, my name is Christopher Britton, and I'm a PhD candidate in the Edge Lab. In the next few minutes, I will give you an overview of our research on social learning networks. Social learning networks, or SLN, encapsulate scenarios in which a number of people learn from one another through interaction. We identify at least 3 SLN applications that have emerged recently. First is Massive Open Online Courses, or MOOCs. MOOC has created a surge in the global connectivity among students for educational purposes. Platforms like Coursera, edX, and Udacity have emerged since late 2011 early 2012. The discussion forums on MOOC are the primary means for interaction. We have instructed 2 MOOCs over 5 offerings on Coursera since fall 2012. The second application is Flipped Classroom, or Flip, which combines elements of online and traditional classroom instruction. With Flip, watching the lectures online become the student's homework, and class time is instead used for discussion. Compared to MOOC, Flip will have a much smaller number of learners with a much denser connectivity among them. We experimented with Flip in fall 2012. The third application is Q&A sites. A number of popular Q&A portals have emerged, such as Stack Overflow, Yahoo Answers, and Wiki Answers. These sites receive thousands of questions each day. We are currently investigating a number of research topics for SLN. Let's go through 3 of those now. First is prediction. The ability to predict performance on assessments a student has not taken is an important research area. Machine learning methods have been used to develop models on data from classrooms. But with MOOC, the amount of questions each student answers is much less, which leads to challenges. Another application is to predict drop-off rates for discussion participation or assignment completion. SLN data can be helpful in detecting student drop-off, and subsequently in modifying courses to increase retention. The second topic is recommendation. There are a huge number of courses available online, and each typically has a rich amount of teaching material and a large volume of student activity in the forums. This presents an opportunity to design intelligent algorithms to assist student navigation within and across courses. Also, collaboration with study partners is an essential aspect of engagement for many learners. In the case of MOOC, sheer numbers makes it very difficult for students to find optimal groupings on their own. Recommendation algorithms could focus on finding these pairings. Third is personalization. Our goal here is to individualize the content that will be presented to each student in a course based on her learning desires and needs. Note that there are a number of existing adaptive educational systems. What remains challenging is to design, implement, and deploy these systems at the massive scale that SLN requires today. We will now outline the general research methodology we follow when studying SLN, which is a 3-step process. The first step is data collection. In general, there are 2 options here. The first is to use existing data. A substantial number of online course offerings remain open even after the session ends. As an example, we refer to our large-scale statistical analysis of MOOC, where we focus on all 80 courses available in Coursera on summer 2013. But the problem with relying on existing data is that it is only publicly accessible to a certain measurement granularity. To this end, the second option is to generate new data. For example, a team could invest resources in creating a brand new online education platform. We have developed 2 learning systems. One is 3 Nights and Done, or 3ND, which is a non-profit free online education platform. Second is the Mobile Integrated and Individualized Course, or MIIC, which is a platform that integrates all modalities of learning into a single app and individualizes the learning experience for each student. Shown here is the UI for MIIC. Once SLN data is collected, the next step is to perform analysis. We will summarize 2 case studies from our previous work. Referring again to our MOOC study, we wanted to understand which factors were significantly correlated with student participation. To do this, we employed linear regression models. The results of this are shown in the table here. 2 of our preliminary findings were as follows. First, a higher level of staff activity corresponded to an increased discussion volume at the beginning of the course, but a faster decline in the volume over time. On the other hand, quantitative and vocational courses both corresponded to a smaller volume of discussion at the beginning, but a slower decline over time. We have also been exploring student score prediction using data from our MOOC courses. We tested the performance of standard collaborative filtering algorithms on our dataset. Using these methods, we were able to obtain close to 80% prediction accuracy. But incorporating SLN data into these models through classification and regression techniques could presumably increase the accuracy over what is obtained here. Beyond SLN data analysis is the design of new learning systems. As an example, the framework in MIIC consists of 3 components: behavioral measurements, data analytics, and content presentation adaptation. Behavioral measurements refer to monitoring and collecting data about the user as she interacts with the course material. This includes information the user enters in discussion forums while interacting with her SLN. The purpose of data analytics is to build and maintain a low-dimensional user model for each student. Finally, the updated user model is mapped to the next set of content to be presented. Using a prototype of MIIC, we carried out 2 trials in 2013. In the first trial, through a post-experiment survey, we found that a number of questions comparing MIIC to OSFA had high statistical significance in favor of MIIC. In the second trial, we found that the total number of pages read by students who received the MIIC app was higher by an estimated 22% relative to the maximum page count of any student. These are just some of the various endpoints that need to be trialed for individualization. Thank you for your attention. If you have any questions, feel free to email me at cbrinton@princeton.edu.